that you're doing here is sort of the precursor to looking at problems that you've known all your life as word problems. We're going to call them story opportunities in this class, because when you say word problems, it kind of sets you up automatically for a lot of anxiety and fear and all that. So we're going to call them story opportunities. But what is critical for being successful with these is being able to represent the unknown quantities that you're trying to solve for with algebraic expressions. So that's why you've had so much work in numbers 1 through 5 here with creating expressions. So, you know, I have very strong feelings about how important this step is, and I'm going to explain to you what I think you should be doing to become sort of masters of the universe here. But I can't create these habits for you. They're really what I think are the best habits for being successful at doing this. But when you go off and do your homework, you're going to probably rely on what you've done before. So the only thing I ask of you is, how successful has this been for you before? How has it been a very comfortable thing? And if it hasn't, hopefully you're a little open today to thinking about changing some of your prior established habits, okay? So it's really critical here, and if you've come through our algebra sequence, or if you've had Sandy, Goki, and you've gone through our packets, I don't think many of you have started in 095 here, but you'll see that we have quite an emphasis on how we define variables. And variables take the place of numbers. So any description you have of a variable, the words should say to the person reading it, which is usually you, or when you're passing something in, it's me. The wording of your definition should always describe a quantitative amount. Okay, so notice here this very first one, where we talk about two different salaries, the amounts of two different salaries, Enzo's and Celia's. Okay, now you have a relationship between those. Now in this one, I think everybody was very successful. You wrote down x plus 150. Probably not much of a problem. But think about it for a little bit, because as we move along, things get a little more interesting. So do you mind getting that for me, Haley? Because the janitor's coming around with his cart. So one of the things, even though you don't necessarily have to do it here, is in your mind you want to think about what is the relationship between these two things. One of these numbers is bigger than the other, okay? So I'm not asking you to solve anything here. I'm just asking you to represent these two amounts. But later on, when you have to do some kind of solving of this using these amounts, it's often important to keep in mind which one of these is bigger or smaller than the other. All right, enough said. So notice I said here X represents the amount of Celia's salary. Again, it's the amount. It's not her salary. You know, it's not this qualitative thing. It's an amount. Enzo's amount is larger, so you always say, all of you said X plus 150, no problem. I won't spend a lot of time talking about this one. Okay. Telephone texting plan has a fee of $20 a month with a charge of 5 cents per text. Write an algebraic expression that models the monthly cost for X text messages. So again, I look around the room and I see this expression on every board. Again, this represents a cost. So for those of you who want a little more challenge, what are the units on all of these pieces? We know, I'll get you started. We know that the units on $20 is 20. Excuse me, the unit on 20 is dollars, which means the only way you can add something to dollars is to have this entire expression represent dollars. This is not just dollars, the 0.05. It has two units attached to it, dollars per text. So if you were writing out this expression and you were just putting units in, not the actual numbers, what would be the units in each one of these boxes, so that when you were done multiplying, it just came out to be dollars? That's something called unit analysis. which if you take chemistry or physics is very critical to your success. Learning how to do this, or if you go into any of the health fields and you're doing dosage calculations, this unit analysis is really a very important skill to have. All right, again, no problem there, so be quiet, Linda, all right? X plus 200 represents the length. Simplify the expression that represents the entire rectangle's perimeter, and most of you were very successful with this. You remembered it was twice the length plus twice the width, and when you simplified that, you got here. Now, where do the problems begin? 4. And it comes down to this idea of what are you trying to represent. 4, you have to represent an amount of money, and then you have to represent interest earned on that money. Those are 2 different ideas. So before you can talk about how much annual interest was earned on that amount of money, you have to be able to express the amount of money. Now, I saw some clever things. We're using one variable here. So on Wednesday, you'll be able to use 2 variables because you'll have more information. So right now, you know that X is the amount that's put in the 2% account. All you know is that the amount in the 2% account, now just the amount, not the interest, plus the amount in the 3.5% account, we know add up to 3,000. So you're often given situations like this where you know a total, and you're asked to represent 2 unknown quantities in terms of that total. So you let one of them be whatever variable you want. In this case, I've already defined it. X is the amount in this 2% account. And then some of you did this, which is kind of a clever way of doing it. X plus Y, you said you're going to let this equal Y, the amount in the 3%, and you know that the total is 3,000. But you know you can only represent this amount with this variable X. So when you solve that equation for Y, which is that other amount, you get 3,000 minus X. So 3,000, take away the amount. See, this is the amount in the account that pays 2%, is what's left over. Your total, take away the amount in the other account. So this is how you represent the actual amount of money. To represent the interest earned on that, you have to say how much money you're putting in, and then you put the interest rate on. Now be careful, some students here make a little mistake. 3.5%, remember, is 3.5% means per 100. So this gets smaller by 2 decimal places. So this represents the amount of interest on the 3,000 minus X dollars invested, okay, on that amount of money invested. Okay, so we're okay there. Now, the last one, you'll see this in your book and in your homework. This one, if I gave you this on a quiz or a test, I'd say solve the following problems by writing an equation and solving it. Okay, you'd have to represent the unknown quantities here, represent it as an equation, and then come up with your answers. So I look around the room and I see number 5 over here has an equation, and number 5 for table 2. Table 1 just put up an answer, which isn't going to get them much credit on a quiz or a test, especially if it's not correct, and I say show all work. And then table 3 said we figured out what to do. They've come up with the answer for 60, but there's no equation representing it. So here's where maybe some of this blah, 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 blah that I'm saying will start to make a little sense. You kind of know what to do. And some of you in the past would just say, just start working with the numbers and trying to get the answer. And that's fabulous because at least it shows that there's some investment thought-wise in the problem. What you need to do is say, okay, every time you come across a problem that you're not quite sure what to do, make it easy for yourself. Say to yourself, what was the price of the camera before the reduction? Let's just say it was $100. You know how to do this problem. It's just taking it from the very specific case with one price and generalizing it. So no matter what this amount is right here, this 276, you will have a process or a formula. Let's suppose we were creating an Excel spreadsheet. You'd have a way of representing how to get that 276. So if my camera started out, so on the side of my paper, I need to think about this, all right? And I'm going to make it easy by picking numbers that are really easy to work with. So let's say this I start with 100. Write down what that represents. This represents the original price of the camera, right? The original price of the camera, right? And then we'll go to the algebra. How do you represent the 40% reduction on that? What would you do if you were doing this with just this amount, just, playing with numbers? What would you try? 40% reduction. Reduce it by $40. And so that's absolutely true. And could you just tell me where the $40 came from, what you did in your head? 40.4 times 100, right? So you took, this is your percentage, and this is your original amount, right? So I'm just going to write it that way. 100 minus 0.4 times 100, and that equals $60, right? We all agree with that? Okay. So if I asked you to look at this expression right here, do you see that the $100 is what's common to each term? And that you have a full $100, 100% of $100 is $100, and then you're taking away 40% of it. So I've just put the 1 there for a minute. So this actually represents 1 take away 1 times 100, take away 0.4 times 100, which is 0.6 times 100. And you know that this is a true statement, 60 equals 60. It doesn't matter what I start off with. I could start off with something like this here, 417, make it really funky. Now I have my process. And now instead of immediately going to $40, you got to think a little bit. You say, I'm going to start now with 417, but I'm going to take away 40% of 417, and that's going to equal some other amount. But you always start with 100% of this, of that number, and you're taking away 40% of that number. So what's left is 60% of that number. So 276 represents 60% of the original amount. So how you get there with an algebraic expression and then an equation is to do the following. Start with the question, what was the camera's price before the reduction? And you say, I don't know. So let's start right there. Let's say X is the amount or the price of the camera. Let's stick with the context here. Price of camera. Let's say original price, because then I don't have to use a lot of words, in dollars. And this is where the ability to really understand what's happening. If I ask you, right, and I'm going to ask you to write this down on your own right now, and then you can talk about it after you take a guess. I want you at your seats just to write down, what does 0.4 times X represent in words? See if you can represent that. Nobody's going to look at what you've written. I'm not going to look at it. Nobody at your table. Just write. You take a shot at representing in your own language what 0.4 times X is. Okay. So someone want to tell me what they wrote down for that? Be brave and courageous. Nobody wants to be brave and courageous. All right. Here we have a brave and courageous Lucas.
So I said it was that 0.4x value.
So the value reduced from the original price. So do you mind if I just say the amount of the reduction? Is that the same thing? Okay. All right. Same. It's really what you said. I just edited it a little bit. That's the actual amount of the reduction, regardless of whether you start off with $100. This would then represent $40. $417, this would represent, I can't do it, 180 something. Okay, whatever it is, okay? These two amounts represent the original price and then how much you're going to take off. So now whenever you're solving these story opportunities, here's now what you have to be able to do. What is equal to what? What, you say? Because you have to solve an equation, so you've got to come up with an equality. And sometimes you could write this out in words for yourself. You know, usually we just go right to the algebra. But you know that the original cost minus the amount of the reduction is going to equal your sales price. The original cost is X. Let's put a 1 in front of it to say the whole thing, the 100% of X. Take away 40% of X is equal to 276. These are like terms. 1x take away 0.4x is 0.6x equals 276. Then you divide both sides by 0.6, and that's what you arrived at as 460. Now, you might say, I don't want to go through all that. You don't have to. You could have done this. You always got to tell me what x is, which is written above. You could have just said 0.6x represents the final price. So if you did that in your head and you wrote it down, then you can go to the what equals what, and you can do this and then solve that. Okay? So there's a lot that goes on in these couple of steps. There's a lot of stuff going on in our brains, a lot of connections being made. And you have to give yourself the time to work on this and do it. Because the only reason I can do it kind of okay is because I've been doing it for a very long time. Anybody ever read the book Outliers? Nobody? One person? Speaking of the Beatles, in Outliers, they talked about people that are really successful at stuff. They start off with National Hockey League players, and then they went to the Beatles, and they said that it takes about 10,000 hours to really become a master of something. So I know you don't have 10,000 hours to spend on story opportunities, but it just gives you a sense. And they said that one of the reasons that the Beatles were so like together beside their talent was because they played for hours on every day when they were in Germany, you know, in those nightclubs before they even got to be, you know, sort of in any place where they could get some coverage. So you have to invest the time, and you have to feel that sense of, I don't know what to do. And you have to find a way to say, what do I do when I don't know what to do? So I showed you my strategy here. I started off with a number that I would know what to do with it, and then I tried to generalize it to the algebra. So it's going to be really easy for your activities today to want to look at the answers or try to invest the time. That's all I'm going to encourage you to do. It's sometimes when things are scary or hard and you get to the end result with a little frustration, it feels really good. You know, it feels really good when it all comes together. All right, so let's do one problem together as a class. We've already talked about this, the story opportunities. So let's begin with this problem, and I'm going to go through a series of steps with you together to show you how you would approach some of these problems. Julian, you want to start us off by reading it? Like this, you want to make sure you understand everything that's going on. You want to make sure you read the axes, the titles. What's going on here is they're showing you average earnings of full-time workers based on the degree that they've earned. Okay, so you see here that the only average salary you can actually pull off of here is $80,000 is the average earning full-time of a full-time worker who has some kind of professional degree. So this could be like a nurse, a lawyer, okay? So you don't know what the average earning is for either a bachelor's or a doctorate. So right away, you know, it's setting you up for some type of story about how much a person earns when they've earned one of those degrees. Now, what's important is if you're going to do it with one variable, there has to be a relationship between these two amounts. They have to tell you something about them. All right. So let's read. Tyler, you want to read, tell us what's happening here with the master's degree and the bachelor's? I know it sounds silly, but you know, every time you look in any textbook that deals with story opportunities, they always tell you to read the problem. You might say, of course I'm going to read the problem, but sometimes we don't read it carefully. There's so much that's going on. We want to like get the equation, get the answer, and based on your past history, that can be either like a good thing or not so successful. So here's this, I think, is these two steps right here are really, I think, the most critical, because if you can get these first two steps, then the rest of it seems to, it's like when you get most of your puzzle done, or if you do crosswords, I do crosswords, it's like sometimes I read a crossword puzzle, like especially if it's Friday or Saturday in the New York Times, and I might have like 4 spaces filled in, and I'm like, I'm never going to get this. But then, you know, you start filling in some other space nearby, and then you start to see, oh, it could only be this type of word. And that's what you've got to do here. You've got to just take your time and carefully construct this. Okay, so it says here, identify and describe in words the quantity or quantities, numerical values that you're being asked to find. Well, that's usually in the last sentence of the last question. There it is. That's what you're being asked to find. You're being asked to find 2 salaries, the amounts of 2 different salaries. And so now you go right from there to this, where you assign a variable, of course, the famous one is X, to one of them. And then you talk about the other amount in terms of X. So how do you decide which one of these things? We're trying to find the amount, the average salary for the person who earns the bachelor's degree, and we're trying to find the average salary for the person who earns the master's degree. Okay, so how do you decide which of these to call X? Let me first start by saying it doesn't matter. You have total freedom. However, one of them, based on the wording in that first sentence, is going to be a little easier to call X than the other. So how do you make that decision? How do you make that decision? Yeah, Haley? Yeah? You use the bachelor's as X? Yeah, because the master's degree is being talked about in terms of X, right? Notice that word in terms of X, that word term comes up a lot in algebra. So the description of the master's, the master's is being compared to the bachelor's degree. So would you agree that the bachelor's degree, based on that, the amount of money people earn on the bachelor's degree is less than the amount of money if you have a master's from that description? $49,000 and twice the bachelor's, the amount earned for the bachelor's. Do you agree that the amount of money that you earn with a master's degree is on average more than that than a bachelor's? Or you don't know? Yeah. Yep. So even just looking at the bar graph. So let's start with X. X is the average salary earned by a full-time worker with a bachelor's degree, let's just call it a BA, BS. Okay. So that's how I start my problem. I never skip this step. Never. Now I have to talk about the average salary earned when you have a master's degree. And it's $49,000 less than twice that of a bachelor's. So I know I've got to double this and then subtract 49,000 from it. That represents a figure. So I'm putting that just so I see that as a simple one item amount, just like I see X as one amount of money here. It's an average. All right, so I actually did this part right here. I've done both of these now. I've got X and I've got the other quantity, which is the average earning for the masters. And now the what equals what is what comes into play. What equals what? To solve an equation, you must determine what two quantities are equal. Can you identify some important information about the unknown quantities in this story that will help us create an equation? So you come back here and you say, well, I've already used all of this information. There we go. I've already used that. It's not going to come into play anymore. Combined. Okay, that's the key. Combined means you know that if you add these two amounts, and here they are, you come up with what? What is 116,000? Okay, 116. Then once you get there, you all know how to do this. It's getting to this point with each of these being playing key roles in your description to get to the what equals what. So we get 3x minus 49,000 equals, hopefully someone out there has a calculator, 3x, I'm going to add 49,000 to each side. And 3x equals 0.00561, is that correct? X equals 55,000. Now remember, this happens all the time when I give students problems to solve on quizzes. I say, make sure you have the units. X is just a number. The unit is in front of X, in this case, dollars. So X is the number. When you actually write your answer, that's when you attach your unit. I know it sounds picky, but X does not have a unit on it. It's the context of the story. When I define what X is, that tells me what the unit is. So don't put the dollar sign here. You can put it in your answer or in your sentence. So now that we know X is 55,000, you want to check your answer. So you say $55,000 plus, now twice 55,000. Just went to erase that. I need more room. Twice 55,000 minus 49,000 is supposed to be 116,000. So you check your work, you find out you're correct, and then you write your sentence. And then you use all the information you have in the problem. So you say the average earnings of a full-time worker with a, you can use some bachelor's degree is, and that's what you put on your 55,000 with the units. I'm getting messy because I'm hurrying because I want you to have plenty of time to work on this on your own. And make sure your sentence describes the context, and then you can say, and the average earnings of a full-time worker with a master's is, well, what's that amount going to be? It's going to be 110, right? Minus 49,000, which is how much? How much? $61,000. Okay. So I've taken the time to lay out this table for you, this chart, so to speak, this strategy, how you can approach everything. This is the type of thing, if you start doing this for yourself, you should hopefully find some success with these story opportunities. So I'm encouraging you to use this. I'm encouraging you to take all these steps. But in the end, I can't be on your shoulder watching, and nor should I be. It's really going to be up to you. And so I'm going to leave you with half an hour almost to 25 minutes to start working on the class activities. I would suggest reading over your class activities. You may want to start, you don't necessarily have to start with number one. Maybe you want to work on one you think might be more difficult. Maybe you want to split it up amongst your group and then talk about them together so you can fully utilize all of the problems. Do whatever you want. It's all right with me.